Assalamu alaikum, dear students. Welcome to the lecture of the classical mechanics. In this lecture, we will discuss the solution for the problem 8. If I minimize this so that we can write it with proper. The question says that if L is a Lagrangian for a system of n degree of freedom satisfying Lagrange equations, okay, show that by direct substitutions L prime is equal to L plus df over dt q1 qn and t also satisfy Lagrange equation where f is any arbitrary but differentiable function of its arguments. Okay, it means this df over dt is additional factor. If we add df over dt f function into Lagrangian, then it also satisfies Lagrange equations. So we will see the effect whether it df over dt, addition of df over dt affect the Lagrangian or not. If it does not change, it means then we have proved our statements. Here first we want to show that under the stated transformation the equation of motion satisfies Lagrange equation where f is differentiable function of coordinate q and t. F depend upon q and t. By direct substitution, the Lagrange of this system will be L prime will be equal to d over dt partial L prime over partial q dot minus partial L prime over partial q. This is the Lagrange equation in term of L prime. So L prime will be L prime is equal to d over dt partial over partial q dot, and L prime will be replaced by L plus df over dt. This is the, because we have to make that substitution. L prime will be equal to L plus df over dt minus partial q, L prime will be equal to L plus df over dt. Now multiply this term and collecting. We will just definitely multiply this term with this with second term. Similarly, this term will this and this with this, and collecting some term together and collecting other term together. So L prime will be equal to this whole term. This whole term is Lagrangian, and this term is additional d over dt partial q dot df over dt partial minus partial q df over dt. This is termed as equation number 1. Okay, now we substitute here something. Df over dt can be written as f dot. Df over dt is equal to f dot. Okay, here, and partial f dot over partial q. Also, we also know that partial f dot over partial q dot is equal to partial f over partial q. This is the derived identity from the basics of the Lagrangian. Partial f dot over partial q dot is equal to partial f over partial q, because we will use this in the later derivations when we proceed. Okay, let's I maximize and fit it to the center so that we can see it. We will L prime is equal to L plus. We will take this term. The first term d over dt partial q dot df over dt, d over dt partial q dot df over dt, and if these term goes to 0, it means L prime is equal to L. The addition of these additional factors does not affect our Lagrangian. So let's see, d over dt partial q dot df over dt, this whole term, we take this whole term, d over dt partial q dot df over dt is equal to d over dt. We know that this term is equal to f dot. So this term will be d over dt partial f dot partial q dot, and we also know that partial f dot over partial q dot is equal to partial f over partial q. So it will become d over dt partial f over partial q. And by total differential, knowing that f is a function of q and t, so if we know that f depend upon q and t, that total derivative can be written as d over dt partial f or partial q will be equal to its total derivative can be written as partial over partial t partial f or partial q plus partial over partial q partial f over partial q and partial q over partial t. We can write the total derivative of this whole functions. Okay, and we know that f depend upon q and t. D over dt partial f over partial q is equal to partial over partial t partial f over partial q plus partial over partial q, this partial f over partial q, and this can be written as q dot. I hope that you will be familiar with the total derivative, how we have proceed. Here is the total derivatives. Taking the partial over partial q as common, we can take partial over this in this expression we can take partial over partial q common. This is a partial over partial q, and this is also partial over partial q, so we can take it common out. Okay, we go to next page. If we take it common, so it will become du over dt partial f over partial q is equal to partial q partial f over partial t plus partial q f into q dot. We know that this whole term partial over partial q, and this term is equal to partial f over partial t partial q partial f over partial q and q dot. This is equal to total derivative of f. This is equal to total derivative of f df over dt if f depend upon q and t. Okay, so this term will become du over dt partial f over partial q will become du over dt partial over partial q will become partial over partial q this term, and this whole term is equal to df over dt. So this is f dot, so partial over partial q and f dot as arguments. So this substituting 2 in equation 1, we find that this is the equation 2. We will put this in back equation number 1. Okay, this is equation number 1 as you are seeing. So d l prime is equal to l plus, in the place of this function we will put the equation number 2, and it will lead to following result. L prime is equal to L plus partial f or partial q minus we have this in the equation number 1 partial f or partial f dot or partial q. So these two terms will be cancelled out, so L prime will be equal to L. It means then addition of the additional factor does not influence the Lagrangian. It means the transformation thus the transformation of the Lagrangian of the system L prime is equal to L plus df over dt has no effect on the Lagrangian of the systems. It also means that there is no unique solution for the Lagrangian of the system, thus the required to be proved. It means कि our required solution is good.